welcome back to the second day of Chapter 5. Today what we're going to be discussing is selecting a trig tool that we've developed the last couple of days. And so as a reminder, as you go into this warm-up problem, we developed some different ratios that we can use in order to help solve for missing side lengths. So remember the one that we did last chapter was saying that the tangent of theta is equal to the opposite leg divided by the adjacent leg. Yesterday we discovered the sine of theta, and the sine of theta is equal to the ratio of the opposite leg divided by the hypotenuse. And then lastly we had the cosine of theta, and the cosine ratio of an angle is the ratio of the adjacent leg to the hypotenuse. So using this information, what I want you to do is select a trig tool and then solve for the value of x on these problems 1, 2, 3, and 4 now in order to help you evaluate what the value of x is in each case. Alright, let's take a look and see how you did on the first one, problem number 1 here. Hopefully you were able to recognize that we should use the tangent ratio, because looking from this angle of reference right here, we have the adjacent leg and the opposite leg. And so the tangent ratio is the ratio of the opposite to the adjacent leg. So I set up my fraction, and I cross multiply and solve, and I ended up getting 21.45. On problem number 2 over here, I used the cosine ratio as from this angle of 49 degrees. I was trying to determine the adjacent leg, and I was given the hypotenuse, and cosine is adjacent over hypotenuse, so I solved and got roughly 49.2. Then moving over here to number 3, I used the sine ratio. Sine is the ratio of the opposite leg divided by the hypotenuse, and from that reference angle of 36 degrees, I can set up this ratio of x over 10 using the sine of 36 and solving it, I get 5.88. And on the last problem, you actually had choice. You could use either the 71 degrees or the 19 degrees as your reference angle. I chose the 71 degrees. Then with that, I ended up getting roughly 82.93 using the cosine ratio. If you did indeed happen to use this 19 degrees as your reference angle, then this side length would rather be the opposite leg. This is still the hypotenuse right here. So in that instance, you'd be using the sine of 19 degrees equals 27 over x, and you would solve that way. But either way, you could use sine or cosine. You end up getting the same answer, just as your ratio is a little bit different in the setup. If you have questions with this stuff, this is one of the most important essential skills in the geometry course. Please stop by, and this is the idea that we're going to develop even more so today. So lesson 5.1.2 says, which tool should I use? And this is really just extending on what we did yesterday in class. Again, this is from the math notes that we did. If you did not get this down yesterday, I would get this picture right here down in your notes somewhere. Just defining what cosine, sine, and tangent are, as they are merely ratios of side lengths within a right triangle. Remember, theta is just the reference angle that you're using, and so you can see where theta is located within each of these triangles. And the emboldened sides within the triangles that you see there are the two legs that you're comparing. And so as we look down here on these problems down here, it says write and solve an equation to find the missing side length. And it says, are there any that you know already that you should be able to do? And so before you even go any further, hopefully you can recognize that in question B, this is a 45-degree angle. And so that these two side lengths here need to be the exact same length. And so that should turn out to be 8 as well. I don't need to do any kind of calculation for that. And then lastly here on letter G, we actually don't need to do anything with that because that has a 0-degree angle, and therefore I don't need to solve for that because that triangle is not possible. So what I'm going to ask you to do is to use these ratios up above, and just like we did in the warm-up problem, write and solve an equation to find the missing length within each picture. So hopefully this will be excellent practice for you, and I will show you my work here in a moment with my worked out solutions. Hopefully your work looks something like what I have right now, and you can see how you're doing with this sine, cosine, and tangent ratio. I think it's pretty straightforward with which one you should be using. I tried to highlight which angle I am using and which set of side lengths, whether it be the opposite and adjacent, or adjacent hypotenuse, and so forth, to try and find my answers. And yeah, solving missing side lengths within right triangles. So again, just to reiterate, we now have 3 trig ratios to be able to use to solve for missing side lengths, an angle at measurements in any triangle. And so this is the same math notes that we took down yesterday. If you have questions on this stuff, by all means, continue to stop by my office hours. Yes, we'll continue to move on with this material throughout the week. Stay safe and stay healthy.